Hello, everyone. My name is Alessandro Ferraris, and I work at Fortum. Um, so, as I said, my name is Alessandro Ferraris. I work at Fortum, and where I am actually responsible for a team working in technology development for our hydropower department. I've been working with my colleagues in Finland and collaborating with our nuclear services in order to help Fermi to understand which are the agreed ancillary services that they will be established in Estonia and in general in the other Baltic countries after the disconnection from the Russian power system, and also understand which are the possibilities for SMRs to participate in these markets and increase the profitability of like an SMR project. Um, the scope of our work is a little bit what I just mentioned, and I just want to point out that we performed this work around maybe 6 months ago after the summer, and some news has been released after that that I will cover a little bit later. But the background of the work of our work is basically, as I mentioned, that we looked a little bit into the background about what is going to happen in the Baltic power system after the disconnection to the integrated power system of Russia. And then we also analyzed which are the different load frequency control process that is going to be established, and these concept documents that were written by the Baltic TSOs. After that, we looked at different opportunities for SMRs and the different participation to different frequency containment restoration reserves. And then we also looked at the possibility to do to provide some other services or benefits to the grid from a more qualitative perspective. In general, like since the main conclusion, as we will see, is that there will be some extra support to SMRs to provide some of these services. Then we also considered something that it was a little bit more in our expertise at Fortum, which are these hybrid systems, and how it would be possible for a battery combined together with the SMR to increase its revenue streams in these markets. Um, Well, the background basically is something, and I guess you will know, is that the Baltic countries are planning to disconnect from the integrated power system of Russia, which is nowadays basically providing all the system stability and these grid services that instead will need in the future to be established as own markets. Um, and to do this, the TSOs have been following the so-called European System Operation Guidelines and proposed some dimensioning criteria in order to establish these markets. And there has been also some work which we have analyzed that is basically assessing the feasibility and the economic impact of introducing these markets. Um, when we look at the dimensioning of these markets, which are presented in this slide, we see that basically the work that the TSOs have been doing following this system operation guidelines has been to allocate the size of these markets proportional to the size of the different countries' power systems in terms of like consumption and production, and with respect to the total continental European area. Um, with our analysis, we thought on taking this a little bit step further and looking at which would be the required reserves in order for the Baltic countries to also to have system stability in case that they are disconnected from the cable, the only AC cable that would be remaining towards Poland. And then The other part that was already announced around 6 months ago is that the TSOs have been also planning and already started installing synchronous condensers in order to keep the minimum level of inertia to 17 gigawatt second. Now, if we jump a little bit to some conclusion or interpretation of these numbers, what we came up with is that the target level of inertia for 17 gigawatt second is actually proportional to what the Nordic countries are. The reason why we use the Nordic system as reference is, well, first of all, because of our expertise in that at Fortum, but also because they are a synchronous system which is sustaining its stability by its own. And as I mentioned before, we wanted to take a little bit this work that the TSOs have been doing to a step further and look at what would happen or what would the Baltic countries need if they wanted to sustain the stability when they are in what is called the island operation. Um, when it comes to SCR, which is basically the primary control or the maybe can be seen the most important automatic reserve that is continuously available, the target of the Baltics is sufficient when it comes to the whole European context, but it's quite limited if we compare this to like the countries to sustain by themselves in case of disconnection. And if we compare to the Nordics, then as you can see, it's a very different order of magnitude. So this basically means that with the increase and the big plans of installing more wind power and decreasing the inertia in the power system, the FCR will need definitely to be increased in order to guarantee the system stability. Once again, in case of disconnection. Um, but when we look at the synchronous um, at the synchronous condensers, what they would provide in terms of inertia, that's also sustainable at the levels of wind integration of today. But of course, with more wind power and less conventional power connected to the grid, that's also probably not sufficient to guarantee like a level of complete stability in the system in case of like major outages. Um, if we look at the revenues and the size of these markets, and the revenues, sorry, for a 300 megawatt electric SMR, we need to look at the parameter in order to consider how much this technology would be able to provide. And what we have assumed here, and I say it's pure assumption, as we have heard today, there are different technologies of SMRs and with different flexibility potential. But what we assume is 1.5 megawatt per minute as ramping potential, which means that one of these SMRs would be able to provide a certain amount of the different reserves, depending on how quick are their requirements for them. Meaning that basically the most challenging from a technical perspective is actually the primary reserve of FCR, while it's more simple for an SMR to provide slower reserves like secondary or tertiary reserves. And here we plotted a little bit some of the potential revenue and scenarios. Um, the Basically, since these markets are not established yet, it's difficult to estimate which would be the prices. But what is presented here is sort of average of what are the average prices for similar markets in other countries, and also a little bit of assumption about different scenarios depending on how the electricity mix would be looking like. Um, but what we can see clearly is that, as I already said, the SMRs are technically more suitable for providing slower reserves like AFRR, meaning that that's where also there would be the most of the revenue. But there, of course, in the context of what I explained before, that would be very useful also to increase this minimum level of inertia and provide some other services which are not currently contemplated to be remunerated. For example, like I'm talking about voltage control or reactive power. Um, are we thinking about batteries? Because as I mentioned, the main limitation for SMRs is the ramp rate, and this means that if we want to produce quicker reserves, we need to combine with some system that gives a boost to the ramp and has the capability to regulate quicker. And this is something that at Fortum we have tried with hydropower units and successful in the FCR market in Sweden. And that's why, since the technological solution would be pretty similar, that's what we are considering here in this context as well. Another example is what will happen in Olkiluoto, where batteries are used as a backup as well to reduce uh, the load loss in case of disconnection. And when it comes to the revenues for SCR markets, we need to look it in not only into the context of like what would such a technology or such a system get from the market that is established, but also in what it has been recognized as being the major challenge for establishing this market, which is the availability of units being able to provide these services. Even if we look at the minimum level that has been estimated by the TSOs, it wouldn't be possible to provide those services that they are needed only with the units that they are supposed to be available in 2030 without what is called the master run operation, which means that the TSO will need to sustain significant costs in order to run power plants that need to provide these reserves when they wouldn't be to produce. And this means that with some system that would be able to provide these reserves, as an example, one SMR equipped with a battery system would be able to provide basically all the FCR needed that is estimated for Estonia. The CSOs would be able to avoid these master run costs, which can be quite significant. And if we compare those to the investment in a battery system, that's of course that would be a very good business case from that point of view. And that's why I guess what I would like to mention today is that there were no news of installation of batteries in the Baltics when we did this work, and that's why we haven't mentioned it here. But if I understood that, that's also a way that the TSOs are looking into in order to solve this issue. Mm, So basically, the conclusion of our work, a little bit in a nutshell, it should be that the Baltic TSOs have proposed a model in order to disconnect from the integrated wire system of Russia and connect to the European system of continental Europe. Um, there are like some different proposal for the sizing of this FCR and FRR resources, but in all the different scenarios, the must run operation of conventional units would be necessary. And another point that was a little bit unclear at the moment when we made this report is which of these units that are now considered must-run operation will actually be phased out or converted, and if there actually will be that capacity that has been estimated to be running in 2030 by then. So this need of must-run operation of some other units would be even more relevant as we go forward. Um, and as I said, the dimension of these resources, it makes sense definitely when it's considered from the context of the European Central European system, but they would be insufficient in case that we are considering the Baltic countries that needing to operate in island operation. And the last point is that SMRs can definitely provide a part of this service, have a very good capabilities of like increasing the system inertia and giving voltage control and reactive power to the system, but they would need some backup, for example, being hybridized with a battery in order to provide the quicker reserves, for example, FCR. That was a quick run through of my presentation, but if we manage, I can take some questions.
Thank you, Alessandro. We have at least one question for you. You mentioned battery storage. Have you considered thermal energy storage, something like the integrated thermal energy storage system in the Moltex design?
No, we have been looking only at the electrical part. So meaning like connecting the battery at the same connection point and using the control phase of the plant in order to give the right reaction to the grid, but nothing to be integrated to the power plant design.
Okay, thank you. And we have another question. Would 0.3 megawatt hour storage capacity be enough for ancillary services? I think maybe it's a little bit...
Depending in which context. If we are referring what I had in my slide, for example, to thinking about a battery connected to the power plant that has 300 megawatt electric capacity and some capability for ramping and recharging continuously the battery, then yes.
Okay, thank you very much.
Thank you.